Maths. What is it for?
In order to apply the concept of function as black box machine, now we are going to focus on lawns surrounded by stone slabs. Square slabs, all identical with side 50 cm, are laid all around a rectangular lawn. The lawn width is equal to the size of one slab, while its length corresponds to a certain number of slab sides. Now here, as shown, some successive examples of lawns in green larger and larger surrounded by square slabs. Consider now two questions. First question, we would like to determine how much slabs are needed around a 6.5 meters long lawn. Second question, with 54 slabs, a lawn is surrounded. How long is the lawn? In order to solve this problem, I suggest the following approach. Initially, we model the problem by a black box that expresses the number of slabs around the lawn as a function of the lawn length, in particular in terms of the number of slab sides. Then, using inputs and outputs, we test if a one-operation machine is suitable. If not, we move on to a two-operation machine like drill exercises. We complete the machine with direct and inverse operations to get the functional expression. Finally, we complete the machine using the values mentioned in the problem's questions and determine the missing values in order to answer them. Now your turn! Now just click here and do this exercise before watching the solution. To model this problem, we consider a black box with input x, representing the lawn's length such that the unit is one side of a slab, as the output y represents the number of slabs surrounding the lawn. Thus, with x equals 1, we get 1, 2, 8 slabs around the lawn. Similarly, with x equals 2, we get 10 slabs around the lawn. And with x equals 3, we get y equals 12. Now we test a one-operation machine. With x equals 1, we could multiply by 8 to obtain the output value 8. However, when multiplying the input 2 by 8, we should get 16, not the output 10. This operation is not suitable. When trying an addition now, we can add 7 to the input value 1 to obtain the correct output value. However, by adding 7 to the input value 2, we don't get the correct output value. So we proceed with a two-operation machine. For the first operation, we try multiplying by 2. Thus, with the input value 1, we get 2 as the intermediate value. Then for the second operation, we add 6. Now we test with the input value 2. 2 times 2 equals 4 as the intermediate value. Adding 6 to 4, we get the correct output value of 10. We finally check with the input value 3. 3 times 2 equals 6 as the intermediate value. And adding 6, we obtain the correct output value of 12. After determining the correct operations for this machine, we express the output y as a function of x. Using the first operation, we get x times 2, that is 2x, as the intermediate expression. Then using the second operation, we get the output expression y equals 2x plus 6. Regarding the inverse operations, starting with the second operation, we perform subtraction of 6. Then from the first operation, we perform division by 2. In order to answer the first question of the problem, we first convert the lawn's length into the number of side slabs. 50 centimeters, that is 0.5 meters,
corresponds to 1 unit. Thus, for a length of 6.5 meters, we calculate 6.5 divided by 0.5 equals 13 units. We now return to the machine with the input value obtained, x equals 13. Performing the first operation, we get 26. Then performing the second operation, we get 32. This means that with 6.5 meter long lawn, we surround it with 32 slabs. In order to answer the second question of the problem, we enter the output value y equals 54. Thus, by performing the inverse operations of the machine, we get the intermediate value 54 minus 6, that is 48. For the input value, we then get 48 divided by 2, that is 24. X equals 24 corresponds to the number of units of side slabs for this lawn. Finally, we calculate the lawn's length, that is 24 times 0.5 equals 12 meters. To summarize, with 54 slabs we surround a 12-meter long lawn.